Hi, I'm Courtney Dumont, a professor at the University of Miami in the Department of Biomedical Engineering, as well as a member of the Biomedical Nano Institute at the University of Miami. I want to share a little bit about bioprinting with you today and just give you a brief introduction of the field because it's a really cool area that's getting a lot of research attention right now because it has a lot of promise in the medical field. 3D bioprinting is such an emerging area of research because it works under the idea that you can custom print an organ for individual patients based on their specific needs. So this works by first getting a medical image of a patient, and there's a lot of different medical images that can be taken, converting that to a piece of code that is used by computer-assisted design software, so namely an STL if you're familiar with SolidWorks or AutoCAD, taking that file and either feeding that directly into the printer or going through additional software such as the slicer software and post-processing software in order to optimize your code for your individual needs. So bioprinters are really similar to 3D printers that are on the market today. So these 3D printers are available at a lot of universities as well as high schools because at this point they can be as low in price as $100 to a few $1,000s. And so how these machines typically work is you'll have a filament which is fed into the machine and then it's heated up and then extruded, and from that you can print whatever structure you want. And so the bioprinter thinks that it's the exact same type of printer, but the coding is all the same. It just is tricking the printer into thinking it's printing a filament rather than a biomaterial or a material that is biocompatible. This is an example of the bioprinter that we have in my lab. It's the BioX bioprinter from Cell Inc. You can actually see there's 3 different print heads, and then there's a bed that holds your plate that you'll be printing into, and the stage can move left to right, up and down, and on that you can print 3-dimensional structures with biomaterials as well as cells. So I had some previous high school students from Miami working in my lab. They actually got this bioprinter up and running, and you can see some of the examples of prints that they ran. So here we have the University of Miami logo, the two-tone U. They also were able to print these cylindrical conduits as well as cylinders in which they were able to change between 2 different printing materials. So they were actually able to use more than one of the printing heads. So this was a really exciting kind of first step in my lab to get this bioprinter to be used more heavily. So I wanted to turn this over to my student, Giancarlo, who's working to get his PhD, and he will tell you a little bit about the bioprinter and how it works.
I'm Giancarlo Tejeda, and here I'm in Dr. Dumont's lab, and I'm here to show you the BioX printer. So this is a printer by Cell Inc. It's a relatively new company, and this is like one of their first models, and it's a really cool printer just because you can do various types of printing with bioinks like the one we have here. This is just like the Cell Inc Start that comes with the printer. You can also use your own materials, also printing with cells. It has a HEPA filter on top, so it creates a sterile environment within the chamber. So turning it on, we turn it on from here in the back, and that gives power to it. I'm just going to close this really quick. Alright, and as you can see, turning on, it has various lights on it. When it finishes printing, it turns green and it's really happy with itself. It's interesting. So here's the home screen. As you can see, you have a few options turning it on and off here at the top corner. Various setting options that which are actually really useful for controlling the print heads and different things, especially when you're switching out the print heads. And then you have three options that you can do. You can choose bioprinting, where you can actually choose like specific files, specific models that you want to print out. Either the printer uses a special coding markup script called G-code, so you can basically code how you want it to look, or you can use an STL file, and the printer will convert it directly from the STL file into its own language and print it out. Here you can kind of see this is just a regular square, and if we choose to preview it, you'll see that that's what it'll look like when it prints out. So I'm going to show you, basically walk you through what you would do to print. So I'm just going to print a very basic cylinder. So the first thing you want to do, we're going to use the pneumatic print head, and so for the syringe, it's just a pneumatic syringe, and here you see it's filled a little bit with the Cell Ink Start Bio Ink, which we got here. It's really easy to do. There's a connector that you can connect it with and push through the amount you want. But this was already loaded, so here you just attach the nozzle at the end. Here it's a 22 gauge nozzle, and this is the tube that is used to push the air through them and control the pressure to push out the bio ink. So from here, you would load it onto one of the print heads. To do that, you kind of have to lower this print head button here, tools, and then clicking the down button, and you can see that it brought down the print head, and here you're just attaching it to where it pushes the air through, and tightening the screw so to make sure it's stable. And then going back here, okay. So, and from here you can pick what you're going to print. And here I've already picked the cylinder that radius 5 by 3 millimeters tall. So as you can see, this is what it's supposed to look like here on the preview. I'm just gonna close this real quick. Sorry about that. And then for the surface, I closed it too early. It's the surface that it's gonna print on. We're gonna do it on a 10 centimeter dish. So as you can see here, right, and inside, and just adjusting it here to the little notch it has for this to make it stable. And then, so here we're picking 100 millimeters, 10 centimeter dish, and here we tell the printer which kind of print head that we're using and what type of material. So here we have a pneumatic 3 mil tube, and we're using Cell Ink Start. So moving on, here this is a step that you can control how you want to set your infill and the different layers. Since this is a pretty basic print job, it's not gonna give you the options because you don't need to be that specific, but you can choose how the infill that you want, with a pattern of infill and what percentage of infill that you want, as well as like the support material along the way. So that can all be controlled from this. And now it gives us the option to actually start printing, and you can see it doing that. We can press done, and then we can pull it out so you all can see it a little bit better. So you can see that it does have a 3D structure. I can move it around. So the Cell Ink Start is not a very like viscous. Yeah, it's not a very viscous BioInk, so I think printing at any higher in Z would kind of make the cylinder itself collapse without any sort of like measure to cross-link it as well. So that's something we have to keep in mind when we're printing using this printer, and like probably use a different BioInk if we want to make a more complex 3D structure as well.
I hope after watching our demo that you've been able to see some of the features and options that go into bioprinting a 3D structure. We printed a really simple structure today, but there's a lot of flexibility on what materials you use and what sort of print parameters you're using, as well as the starting out code. So we started with a cylinder, but you can imagine that if we wanted to print an organ, all we need to do is develop the CAD software or the specific code software associated with that organ to instruct the printer on what to print. So there really are no limitations other than your imagination and your ability to use this tool. So thank you for joining us, and I hope you enjoyed our time together.